Okay, so this is the video lesson for 11.3 geometric sequences and series. We saw in our last video about sequences and series just in general, closed and recursive, and now we're going to talk about a specific one, the geometric sequence. This is generated when we start with the number a and we repeatedly multiply by a fixed non-zero constant r. Why do you think that has to be non-zero? Right, because it would be really boring because it would just be 0, 0, 0, 0. So a is considered the first term and r is considered the common ratio. You want to know this phrase. It says the nth term. Remember, nth term could be a specific term we're talking about that we don't know, but it also means just the equation. Okay, so it says find r and a sub n for the sequence. Now, if we see in our equation we have a, which is the first term, and we have r to the power of r to the power of n minus 1. You might have also seen this a different way. You can also write this, and this ties more into exponential. You can just do r to the power of n and use the 0th term. Okay, this is also optional. We don't really need either one of these on number 1 because it's saying find r, or for the first part, so find r. So r is whatever you're multiplying by. So we can see here easily that we're multiplying by -5. Okay, so now we need to write the rule. Okay, so since the first term is 2 and r is -5, the rule is really simple to write. It would not make sense on this to go with the other one that's more like the exponential parent function, because then you'd have to find the 0th term. All right, so this is a different type of question. It says the third term of the geometric sequence is 128, and the sixth term is 54. So I'm going to write that out, and then now we need to find the fifth term. So obviously you could use logic to figure out what you're multiplying by, and then go back one from 54 to figure it out. I'm going to use algebra. So going from the third term to the sixth term, how many times are you going to be multiplying by r? 3 times. So, so 128 times r cubed, because it's times r times r times r, is going to be equal to 54. This is just a more systematic way of solving it. So then that means that r cubed is equal to 54 over 128. Now, if you can simplify this, you would want to. And since r cubed simplifies to 27 over 64, this makes this a little bit easier to do because it's easy to take the cubed root. This tells me that r has to be the cubed root of 27, which is 3, and the cubed root of 64, which is 4. So r is 3/4. So this is what you're multiplying by each time. So we could work to come up with an equation. We don't really need to. In order to find the fifth term, I just need to go back one from the sixth term. So instead of multiplying 54 times 3/4, I'm going to actually divide by 3/4, which would be the same thing as 54 times 4/3. So that ends up being 72. Okay, so now we're looking at the summation of geometric sequence. We have a formula here. Don't worry about memorizing this formula for the time being, but this is what a geometric series is. Okay, so it says find the following sums. The first 8 terms of this series. And so if we know the first term and we know r and we know how many terms there are, this is pretty simple. So we're finding the sum of the first 8 terms, the first term being 2, 1 minus, what's r here? You might have to do a little bit of work to figure that out. Here it's pretty simple though, it's -3. I'm going to put -3 in parentheses. I'm going to take that to the 8th power. So then I have 1 minus -3 in the denominator. And we're getting to where you'd need a calculator to solve this. You get -3280. Okay, so then on part B, it's a little bit different because you're not writing it out. They're giving us a in sigma notation. So we have to find the first term. We need to also find out how many terms are. The first term in this sequence is a sub 3 because we're starting with the 3 down here. So you need to do 5 times 1/2 to the 3 power. All right, and that gives us 5/8 when it's all simplified out. All right, Then we need to figure out how many terms there are. You may remember this from last year being not tricky, but you have to think about it. Can't just divide, or can't just subtract 7 minus 3. That's not including both of those endpoints. You actually have to add 1 to that, or you could just count it on your fingers, but that is 5 numbers. 3, 4, 5, 6, 7, that's 5 numbers. So you need these two things. This right here, even though it's a 3, that's your first term. That's going to be your A in the formula. So the sum is going to be your A, which is 5/8, times 1 minus R, and R is always going to be this number being taken to a power. And put that in parentheses, to the n power, which is 5, divided by 1 minus 1/2. Now again, this is really getting into where you wouldn't, it's not necessary to have a calculator, but you would have a calculator because the numbers are so messy here. And you're going to get 75 over 128. Really want to encourage you to type this out into your own calculator and make sure you get the same number I get. Okay, so now let's look at this next part. It says, consider a big yummy birthday cake. It is so tempting that you sit down and eat half of it all at once. A couple of hours later, you eat half of what's left. A little later, you eat half of what's left, and you continue this process. And so how long would this continue? How long will you always have half left so that you can eat? Okay, mathematically, theoretically, really, it's forever. Okay, now the piece will become so small at some point that you really can't even see it, but you could have half. This is like half-life of particles. This is half-life of, radioactive material, carbon, things like that. So it says, write a series that represents the amount of cake you've eaten. So remember, you first eat a half of the cake. And when you eat the half of the half, that's going to be a fourth. So I'm going to add, because you've eaten all this, so we got to add it up. Then what you're eating is an eighth, then a 16th, and so on. Okay, now if we want to write this in sigma notation, we're going to start with 1, and we're going to stop. We're not going to stop, so we're going to put infinity. Okay, remember the first term? First term right here is 1/2, and R is also 1/2. So we're going to use that formula. You could have also used the other one where you start with the 0th term. The 0th term here being 1, because that's how much cake you had before you started eating. And then you would put 1 over 2 to the k power. And I actually made a little mistake here. This should have been k since I started with k. Okay, so it says no matter how many terms you add to the sequence, the sum will never exceed how much cake can you only eat? 1. There's 1 cake. So as n approaches infinity, the more times you're eating cake, the amount of cake you're eating is approaching 0. All right? Or we'll say the amount of the piece of cake that you're eating. But your sum of your cake, your total amount eaten, that is going to approach 1. Okay, so we get this idea that in an infinite geometric series, we can take the sum as long as R is less than 1. And there's absolute value bars there because it could be negative or positive, but we need it to be less than 1. We need our pieces to become smaller and not larger. Otherwise, it would just approach infinity. So we have this new formula. Now this is one that is going to be worth for you to memorize. So go ahead and put this in your notes, and we'll talk more about that in class. But notice that it's a much simpler formula. The reason this works out is if you think about it. If you go back to our original formula, if n is infinity and a fraction is going to infinity, this whole term really is going to approach 0. Okay, 1 minus a fraction to the infinity power is going to approach 0 when n approaches infinity. So that's why you're left with a simpler formula. That may help you remember it. Okay, so then we have this sum. We got to find the sum. So what is your R here? From term to term to term, what are you multiplying by? A tenth. And so you could write it as a tenth, you could write it as 0.1, doesn't really matter. So if you're trying to find the infinite sum, all you need to know is the first term, 0.3 over 1 minus 0.1. And this does simplify to 1/3. Okay, last problem. It says a tennis ball is dropped from a height of 24 feet and it rebounds 40% of the height from which it falls on each bounce. What is the total vertical distance the ball travels? Now, it doesn't say 10 bounces or 10 bounces, 20 bounces. It just says total. So we're looking at an infinite sum, okay? So let's think about this. I'm going to actually draw a picture. Here's the initial height that we have, 24. It bounces and it goes back up and it bounces, and every time it's 40%. So I don't know if my picture is very accurate, but you get the idea. Okay, so the first time it falls is 24. That's your A term. What is your R? The 40%, really 0.4. So 1 minus 0.4. Now, I do have a problem with this. This isn't my final answer, because what this is really only going to do is find the pieces that it's falling. Okay, so we're going to have to fix that in a minute, but let's go ahead and solve for what is 24 divided by 1 minus 0.4. That turns out to be 40. Again, you can use your calculator there. And 40 needs to be doubled. That's still not my answer. That's 80. 80, though, would imply that there's a going up on the very first one, and there's not, so I got to subtract out that 24. Now, I realize this is a lot of steps, but they should all make sense, and you did do this last year in Algebra 2, so hopefully this is just a review. Bring your questions to class.